Hello here, Ryan Winterhalter doing my Skill 13 Honors Pre-Calculus video. So the problem here was choose an integer a is greater than 2,000 and a rational number b such that b is greater than 3 but less than 5, and b has no digits that are 0 when it is rounded to the hundredths place. Determine the difference in the monthly payment on a 15-year mortgage and a 30-year mortgage if the purchase price on the house is A and the fixed interest rate is B. So for my problem, we chose A as $500,000 and then B as 4.12% interest. So first we have to find the equation to find the monthly payment. This equation is M equals P times J, or I, which is the interest rate, divided by 1 minus, and in parentheses 1 plus J to the power of negative N, where M is the monthly payment, P is the amount of money borrowed on the loan, J is the interest rate, the effective, not the annual, and N is the total number of payments. So then we have to identify all of our variables here. For P, the amount of money borrowed, it's $500,000, which is why we can plug that in right there. To get the effective interest rate, we take the annual interest rate of 4.12% and divide it by 12 because we're paying monthly. So that goes there and in the parentheses there. So that replaces the two J's, or I's, as you may see it sometimes. And so this problem on this side is the exact same as the one on this side, but the only difference is the total number of payments is different. On this side, we are paying 12 times a year for 15 years. On this one, we were paying 12 times a year for 30 years. So we just have to plug in those two different variables. Over here, we have 15 times 12, as you can see. And then over here, we have 30 times 12. That's the difference here in the two problems. So then we just solve simply making sure we follow our order of operations, and then here we get our monthly payment of $3,728.58, and over here we get a monthly payment of $2,421.80. So now the problem here is asking for the difference, correct? So what we have to do is simply, just after we solve for the two monthly payment amounts, we just now have to subtract the two. We're going to subtract the 30-year mortgage value from the 15-year mortgage value to get $1,306.78. So in conclusion, for the 15-year mortgage, you will pay $1,306.78 more per payment than the monthly payment for the 30-year mortgage. Now with the 30-year mortgage, you will be paying twice as many payments, because you are paying 30 years rather than 15 years, and you're paying 12 times a year. 30 times 12 is double 15 times 12. So basically, for the 30-year mortgage, you will pay twice as many payments, but when we just look at the monthly payment, for the 15-year mortgage, you will pay $1,306.78 more per payment than the monthly payment than that for the 30-year mortgage.